A bullet of mass 10 grams is fired from a gun of mass 6 kgs with a velocity of 300 meter per second. Calculate the recoil velocity of the gun. So here we got to separate the information. We see that the mass of the bullet is 10 grams. So we put here mass of the bullet, which is taken as M1, is 10 gram. But we cannot work in gram, we have to work in kg, so 10 over 1000 kg. The mass of the gun is 6 kg, so this is 6 kg. And the bullet is fired with a velocity of 300 meter per second. Now remember, the initial velocity of the bullet is 0 because it is at rest. It is now fired with a velocity of 300 meter per second. The initial velocity of the gun is also 0 because initially the gun is at rest. Then after it is fired, it has a recoil velocity of, say, x, which we call as v2. By the law of conservation of momentum, we have initial velocity, that is m1 u1, plus initial velocity of the m2 u2 will be equal to m1 v1 plus m2 v2. Let's go ahead and put the values. We know m1 here is 10 over 100, 10 over 1000. u1 we know is 0. Here m2 is that of the gun, 6. u2 is 0, equal to m1 is that of the bullet, so it is 10 over 1000. This is 300 v1 plus m2. m2 we know is 6, and the v2 we do not know, so we put that as x. This would be 0 plus 0 equal to, this cancels out, this cancels out, so 3 plus 6x. So 0 equal to 3 plus 6x minus 3 equal to 6x, which means now x equal to minus 3 by 6, and x is minus 1 by 2 meter per second. Now why did we get the negative sign? So here the velocity of the gun we got as minus 1.2 meter per second, and if you remember, that of the bullet was 300 meter per second. Now why this negative sign? This negative sign indicates that the gun recoils, which means if the bullet is in the forward direction of 300 meter per second, the gun is in the opposite direction of half meter per second. So the velocity of the gun is 0.5 meter per second in opposite direction. A car of mass 1500 kg traveling at a speed of 25 meter per second collides with another car of mass 1000 kg traveling at 15 meter per second in the same direction. After collision, the velocity of the car A becomes 20 meter per second. Calculate the velocity of car B. So to start with, we'll take for car A, we'll calculate the initial momentum of A. Now initial momentum of car A will be mass of the car into its initial velocity. Now we know the mass of the car is 1500 and its initial velocity is given as 25. So when we multiply this, we get 37500 kg meter per second. That is the initial velocity of car A. Next, we will now find the initial velocity of car B. initial momentum of car B, which is mass of the car into the initial velocity. So the mass of the car here we see of B is 1000 and the velocity is 15. So initial velocity of car B is now 15,000 kg meter per second. The next step we find is total initial velocity, total initial momentum, or total momentum before collision. That will be of A plus of B. This is A and this is of B. Total momentum before collision. This is of A plus 15,000 of B. And when you add this up, you get 52500 kg meter per second. So we have found the momentum before collision. Now let's go ahead and find the momentum after collision. So we do momentum after collision. And this is of A, which is mass of A into the final velocity of A, because this is after collision. We know the mass of A is 1500. And after collision we see the velocity A becomes 20 meter per second. So this is into 20. So when you add this up, you get 30,000 kg meter per second. This is for A. Now let's go and find momentum. This is what we found now is momentum of A after collision. Now we'll find momentum after collision of B. So to find that, it will be mass into final velocity. Now the mass of B we know is 1000 kgs, but the final velocity we need to find. That is a question, final velocity, and we'll take it as x. So it will be 1000 x. So total collision, total momentum after collision equal to collision momentum of A and momentum of B. So that would be 30,000 plus 1000x. By law of conservation of momentum, total momentum before collision will be equal to total momentum after collision. And we have already calculated momentum before collision as 52500, and after collision 30,000 plus 1000 V or 1000x. So we have 52500 minus 30,000 equal to 1000x. This is 1000x. Here you get 22500 equal to 1000x, x equal to 22500 over 1000. So the V or the x, the final velocity, x will be equal to 22.5 meter per second. So velocity of B after collision equal to 22.5 meter per second. A bullet of mass 10 grams moving with a velocity of 400 meter per second gets embedded in a freely suspended wooden block of mass 900 grams. What is the velocity acquired by the block? So let's see what happens before collision. Before collision, we have the bullet. We calculate the momentum of the bullet. The bullet is moving, so it has a mass into its initial velocity. Now we see the mass is 10 grams, so it will be 10 over 1000, and its velocity is given as 400. So 400. So this will be the momentum of the bullet before collision. So we cancel these out, which is 4 kg meter per second. And this bullet is now hitting a wooden block. So for the wooden block, here is a wooden block. The mass of the wooden block is given as 900 grams, which is 900 over 1000 kg. And the velocity of the block, it's at rest, so the velocity is 0 meter per second because it is at rest. So the momentum of the block is initial momentum. What we are calculating is initial momentum is mass into initial velocity. Mass is 900 over 1000 into 0 velocity. So initial momentum is 0. So total momentum before collision will be momentum of bullet plus momentum of the block. Now momentum of bullet we saw was 4, block was 0, so total momentum before collision is 4 kg meter per second. Now it's time to find the total momentum after collision. Now after collision, we see that the bullet gets embedded in the wooden block. So if this is the wooden block, which is 900 gram, and then the bullet gets embedded in it, and this is 10 gram. So the total mass after collision will be 1000, will be 910 gram. So mass is 910 gram, which is equal to 910 over 1000 kgs. Remember, this is the mass of bullet plus the block, because the bullet gets embedded in the block. Now we need to find the velocity. The velocity after collision is not given, so we'll take it as x. Therefore momentum after collision equals 910 over 1000 into x. So this cancels out. 91x over 100 is the momentum after collision. Now by the law of conservation of momentum, total momentum before collision equals total momentum after collision. Before collision we saw the momentum was 4, and after collision it was 91 over 100 into v, or maybe we could take it as x. So v equal to 4 into 100 over 91. And you work this out, it becomes 4.4 meter per second. So the bullet plus the block will now move with a velocity of 4.4 meter per second. A 60-gram bullet from a gun 5 kg leaves with a speed of 500 meters per second. Find the speed velocity with which the gun recoils or jerks backwards. So here again we have to find the momentum before collision. Now before collision, we know that the bullet, or before firing, the bullet is at rest, so the momentum of the bullet is 0 because velocity is 0, and the gun is also at rest before firing, so the momentum of the gun is also 0. So total momentum before collision equal to 0 kg meter per second. That's the momentum before collision. Let's go and find out what is the momentum after collision or after firing. So after collision or after firing, here we see for bullet, momentum of bullet equal to mass into velocity. Mass is 60, so that will be 60 over 1000 kgs into velocity of the bullet is given as 500. So this is 500. So you cancel these two here. So it becomes 30 kg meter per second. Now for the momentum of the gun. So momentum of gun equal to mass of gun into its velocity, recoil velocity. The mass of the gun we know is 5. The recoil velocity we do not know, so we just put it as v. So this will be 5v. So momentum after collision will be total momentum now after collision will be that of the bullet, which is 30, plus that of the gun, which is 5v. So by the law of conservation of momentum, total momentum before impact or before collision, which in this case we know total momentum before collision was 0, equal to total momentum after collision. And in this case, total momentum after collision we know was 30 plus 5x. So we have to solve this. 0 equal to 30 plus 5x. Now the 30 comes on this side, so minus 30 equal to 5x, x equal to minus 30 over 5. So x equal to minus 6 meter per second. This is the recoil of the gun. Now why did we get a negative? Because if the bullet is moving in the forward direction with 500 meter per second, the gun is moving in the backward direction with 6 meter per second. So it recoils. So the recoil velocity of gun equal to 6 meter per second. A 10-gram bullet traveling at 200 meter per second strikes and remains embedded in a 2 kg target which is originally at rest but free to move. At what speed does the target take off? So before collision or before firing, let us see what is the total momentum. So we need to know momentum of bullet, that is before collision. It will be mass into velocity. So mass we know is 10 grams, which has to be converted into kg, so 10 over 1000, and the velocity is 200 meter per second. So we cancel this out, we get 2 kg meter per second. This is the momentum of the bullet. Now the second, this was 1, we have another body, that is the target. So we need to calculate now momentum of the target. The bullet hits the target. Now the target is at rest. So the momentum will be mass of the target into velocity or initial velocity of the target. But the target is 2 kgs. However, it is at rest. So velocity is 0. So total momentum will be of the target will be 0 kg meter per second. Now total momentum before impact, that is before firing or before collision, will be momentum of the bullet, I'll just put it as P of bullet, plus momentum of target. Now momentum of bullet is 2 and of target is 0. So total momentum before impact is 2 kg meter per second. Now after collision, let's calculate the momentum of bullet after collision, which is mass into velocity. The mass of the bullet we saw was 10 grams over 1000 kgs. Now the velocity of after collision, we know this was a target, and then the bullet was embedded in the target. So here we have to calculate, in fact both, we have to calculate the momentum of bullet plus target together. So this is what we did, was not right, it was mass into velocity. Here this should be the mass of bullet plus target, and both of these move. So let the velocity be x or v. Now the bullet is 0.010 plus 2 kgs is the target, and this is the velocity. So 2.010 v will be kg meter per second, will be the momentum after impact. Next, we know by law of conservation of momentum, we have momentum before impact equal to momentum after impact. So total momentum before collision or before impact equal to total momentum after collision or after impact. Total momentum before impact was 2 and after was 2.010 v. So we got v equal to 2 over 2.010. Now we need to solve this. So here's the velocity. We'll remove the decimal. So to remove the decimal, this becomes into 1000 because there are 3 decimal places down. And when you calculate, 0.99 meter per second is the answer. So which means after the bullet, here is a target, and after the bullet strikes the target, they both then move together with a speed of 0.99 meter per second. A ball X of mass 1 kg traveling at 2 meter per second has a head-on collision with an identical ball Y at rest. X stops and Y moves off. Calculate the velocity of Y after the collision. So here we have 2 balls, identical balls, means they have the same mass and they collide with one another. So let's see the total momentum before collision. So before collision, we need to find the momentum of A. To find the momentum of A, it will be the mass of A into velocity before collision. The mass of A is 1 kg and the velocity is 2 meter per second. So 1 into 2, which is 2 kg meter per second. That is for ball A. We have yet another ball it collides with, that is Y. So we need to find momentum of Y. Of course, this is not A, this is X. This is Y. Will be mass into velocity. Now the mass of Y is the same. They said it's identical. So the mass of Y will also be 1. And Y is at rest, which means velocity is 0. So momentum will be now 0 kg meter per second. So total momentum before impact will be momentum of A, or that is X, not A, plus momentum of B, or Y, that is 2 plus 0, 2 kg meter per second. Now for momentum after the collision. So first we will calculate momentum of X after collision, that is mass into velocity. The mass of X we know is 1 kg, and here they said X stops. If X stops means the velocity of X is 0. So it will be 0 kg meter per second. Next we do momentum of Y. Momentum of Y is mass into velocity. The mass of Y is 1 and we need to find the velocity of Y. So we put it as V. So momentum is 1 V kg meter per second. So total momentum will be momentum of X plus momentum of Y, that is 0 plus 1, and this is 1 V. So by the law of conservation of momentum, we have momentum before impact equal to momentum after impact. Equal to momentum after impact. Now before impact we know the momentum was 0, after impact it was 1 V. So we have V equal to 2 meter per second. Therefore the answer, Y moves with a velocity or a speed of 2 meter per second after impact. A boy of mass 50 kgs running at a speed of 5 meter per second jumps on a 20 kg trolley traveling in the same direction at 1.5 meters per second. What is the common velocity? So now before collision or before impact, here we have the boy, so we have to calculate the momentum of boy, which is mass into velocity. The mass of the boy is 50 kgs and is running with a velocity of 5 meter per second. So which is 250 kg meter per second. Now this boy jumps onto a trolley. So we have to now find the momentum of the trolley. So the momentum of the trolley will also be mass into velocity. So mass of the trolley is 20, and they say the trolley is moving with a velocity of 1.5. So total momentum here will be 30 kg meter per second. That is the momentum of the trolley. In the next step, we have to find total momentum. So we've got to add the momentum of the boy plus the trolley. So total momentum equal to momentum of boy plus momentum of trolley. So of boy is 250, of trolley is 30, so total momentum is 280 kg meter per second. Now to calculate momentum after collision. So we need to calculate momentum of boy plus of the trolley, because the boy and the trolley now move together after collision. So that will be mass into velocity. Now the mass will be mass of the boy, it's 50, plus mass of the trolley, that is 20. Velocity we do not know, that is v. So that is 70 v is momentum after collision. So by the law of conservation of momentum, we have momentum before impact equal to momentum after impact. Now momentum before impact we calculated as 280, and after impact was 17 v. So v will be 280 over 70, and that is 4 meter per second equal to v, which means after impact you have the trolley, and over the trolley is the boy, and they both move together with 4 meter per second after impact. A girl of mass 10 kgs jumps out of a rowing boat of mass 300 kgs onto the bank with a horizontal velocity of 3 meter per second. With what velocity does the boat begin to move backwards? So here is a boat which is at rest, and then this girl is also at rest. This is before the girl begins to move out of the boat. So both are at rest. So before collision or before impact, we have to calculate total momentum. So we have momentum of girl equal to mass of girl into velocity. Mass of girl is 50, velocity 0, so 0 kg meter per second. Then we will do momentum after impact. Not after impact, momentum of the boat. This is all before collision. So mass of the boat into velocity. So mass of the boat is 300. However, the boat is again at rest before collision. So the total momentum now is 0 kg per second. So total momentum before impact of the whole system will be equal to 0 plus 0, that is 0 kg meter per second. Now let's see what happens after impact. That is when the girl moves out of the boat. Now here the girl is moving out of the boat with a speed of 3 meter per second. And we know that the boat will move back. We have got to calculate the speed. Let the speed be v. So after impact, we have to calculate the momentum. So we first do momentum of girl, and the momentum of girl will be mass into velocity. Mass of the girl is 50. She's moving forward with a speed of 3. So that will be 150 kg meter per second. We also have to find the momentum of the boat. Now the boat is going to move backwards. The momentum of the boat will be mass into velocity. Mass is 300 and the velocity we do not know. So we put it as x. So that will be 300x. So total momentum of both the boat plus the girl will be 150, that is of the girl, plus 300, that is of the boat. By the law of conservation of momentum, total momentum before impact equals total momentum after impact. Now we saw total momentum before impact is 0 because both were at rest, the girl as well as the boat. But after impact it was 150 of the girl and 300x of the boat. So when we solve this we get minus 150 equal to 300x, and we'll get x equal to minus 150 over 300. So x equal to minus 1/2 meter per second. So x equal to minus 0.5 meter per second. Why did we get this negative sign? The negative sign indicates that the boat moved in the opposite direction, moved backwards. The girl moved forward while the boat moved backwards or in the opposite direction. So if the girl moved this forward with 3 meter per second, the boat moved backward with 0.5 meter per second. A truck of mass 500 kgs moving with a velocity of 4 meter per second collides with another truck of mass 1500 kgs moving in the same direction at 2 meter per second. What is a common velocity just after the collision if they are to move together? So here we are dealing with two trucks, so let us see the total momentum before collision. So for truck 1, the momentum before collision equal to mass into velocity. So we know the mass is 500, the velocity is 4. So this is 500 into 4, and this would be 2000 kg meter per second. Now we get on to truck 2. So we got to find the momentum of truck 2 before collision, and that is mass into velocity. Truck 2 is 1500, velocity is 2, so you add up, it is 3000 kg meter per second. Now total momentum before impact will be momentum of truck 1 plus momentum of truck 2. Momentum of 1 is 2000 and of 2 is 3000. So we have 2000 plus 3000, which is 5000 kg meter per second. Now we have to find the momentum after impact. So now after collision we need to find total momentum. So for truck 1, in fact we find the total momentum because both of them move together. So total momentum after impact or after collision will be again mass into velocity. Now they are moving together. Here it's given there, they move together. That means the mass will be mass of one truck, 500, plus the mass of the other truck, plus velocity is what we need to find out. This is into, not plus. velocity says v, so this will be now 1500 plus, so 2000 v. So by the law of conservation of momentum, we have total momentum before impact will be equal to total momentum after impact. So total momentum before impact is 5000 and after impact is 2000 v. So v will be 5000 over 2000, so v will be 2.5 meter per second, which means both the trucks now will move together with a velocity 2.5 meter per second. The velocity of a body of mass 10 kgs increases from 4 meter per second to 8 meter per second when a force x on it. So I'll just get on to the question straight on. In the first part, we have to find what is the momentum before the force x. So momentum, we know, is mass into velocity. Here we see the mass is 10 kg and the initial velocity is 4 meter per second, that is u, 4 meter per second. So the momentum will be 10 into 4 initial, that is 40 kg meter per second. Now for the next part, they say what is its final after the force x. So after the force x, we see the velocity is 8, that is v, 8 meter per second. So for b, for momentum after impact, equal to mass into velocity. Mass is 40, velocity is 8, not 40, mass is 10, which is 80 kg meter per second. In the next part, what is the gain in momentum? So we have to find here what is the gain in momentum per second. So to find the gain in momentum is final momentum 80 minus initial momentum. So gain in momentum is 40. Here it is said to find out gain in momentum per second. Per second, that is 40 gain in momentum, divide by this whole change takes 2 seconds, right? So the change takes 2 seconds, that means over 2, and that will be 20 kg meter per second will be the gain in momentum. The last is what is the value of force. Now if you remember, force also is gain in momentum per second. So force is also 20 Newton, because force is also equal to gain in momentum per second.